Before we start the actual content of this presentation, you should know that this video has been recorded for use in more than one class. As a result, there may be some things in this video that do not apply to the specific class that you are taking. Please just consider that an added bonus at no extra charge. This particular presentation will cover a number of financial tools used in analyzing simple investments. In other presentations, there will be other tools examined for more complex analysis. I should also add that the formats have been pre-entered into this video to save time on the video. You most likely won't have that luxury if you are doing this in the real world. So let's get started. The first financial tool examined explains graphically how compounding interest works. As I say in all of my videos, the uses and workings of these tools and principles are explained in your textbook or on the web. These videos are just to show how to calculate the numbers and to show in what format the numbers are usually presented. This first example illustrates how compound interest works. Before actually starting on the computations, it is important to have the data that is needed for the computations. The first three lines on your screen are the places to put that. $250 is the present value, as shown in the instructions as a $250 deposit. The interest rate shown in the instructions is 2%, and the number of periods is 3 years. It is important to recognize that interest rates are almost always quoted as an annual number, unless otherwise specified. To keep this simple, we are just working in years for the problems in this video. There are two schedules on the screen in front of you. The first is an expansion of what you will typically find in a textbook. In order to illustrate the process, the annual interest earned has been added in between each year and number. As the numbers on the longer format on the screen are filled in, the numbers on the typical book example towards the bottom of the screen will fill in automatically. To start filling in the numbers in the schedule, $250 has already been automatically put into the workbook cell under period 0. To calculate the next cell on the right, type an equal sign, highlight the 250, type an asterisk to denote multiplication, highlight the annual interest, since this is an annual analysis, and press Enter. The interest earned for this first year is $5. With a beginning balance of $250 and interest earned of $5, the balance at the end of the first year is $255. To calculate that, type an equal sign, highlight the 250, type a plus, highlight the $5, and press Enter. It would seem that the easiest way to do the interest earned in the ending balance for year 2 would be to copy the interest earned and the year 1 formulas over 2 cells. However, that will not work as copying Excel formulas moves everything relatively. You may try it on your own to see how it works. As a result, the easiest way to calculate the next interest earned is to type an equal sign, highlight the 255, type an asterisk, highlight the 2%, and press Enter. This time, in the workbook cell under year 2, type an equal sign, highlight the 255, type a plus sign, highlight the $5.10, and press Enter. At the end of year 2, there is now $260.10 in the bank. Year 3 works just about the same. And when the formulas are all entered, and all is said and done at the end of year 3, there should be $265.30 in the bank. While this looks very simple, it illustrates the principle of compounding. Notice that the typical book example has filled in as promised. There is typically a formula available in the textbook that will illustrate how to do this kind of a problem without the extra steps of separating the interest earned, like was just done. There are other, easier ways to complete the same calculation. This next example uses the formula approach. The finance formula that is illustrated in the format on the screen will also complete the process. Using the same numbers, the formula is filled in and should come up with the same answer. The source numbers are the same, so they are already filled in. The numbers are entered into the format as $250 under PV, 2% under I, and 3 under N. To enter the formula, type an equals in the cell under FV, highlight the 250, then type an asterisk, an open parenthesis, a 1, and a plus sign. Highlight the 2%, type a close parenthesis, type a caret denoting raising a number to a power, highlight the 3, and press Enter. The 265.30 is exactly the same number that was calculated in the prior schedule. But wait, there are 2 more ways to do this to come. The spreadsheet approach again uses the same numbers, but uses the Excel future value function. This time the $250 is typed into the cell under PV, the 2% is typed into the workbook cell under I, and the 3 is typed in the workbook cell under N. The formula is a bit more complicated, but the program will help you with it as you go along. For this example, the formula would just be typed in. In the workbook cell under FV, type an equals, FV, and an open parenthesis. Highlight the 2%, type a comma. Highlight the 3, type a comma, type a 0, and another comma. Type a minus sign. Highlight the 250, type a close parenthesis, and press Enter. One thing to remember about Excel functions is that often there will be a number that has to be preceded by a minus sign. In this case, it is the PV. In most classes and in the real world, it is unacceptable to forget that minus and have the answer be a minus $265.30. Also, the 0 that was put into the middle of the function is every bit as important as the other numbers that are in there. If it is left out, the answer will be incorrect. The last way that will be covered on this video to do exactly the same calculation is to use an amortization table. These tables are typically found in finance books, at the library, or on the web. For the 2 examples being used in this presentation, they were found at accountinginfo.com. When using amortization tables, it is very important that you use the correct table. The tables being used in this particular video are only for single amounts, not annuities, which of course are streams of payments. One table is for future values and the other is for present values. Again, the input numbers are exactly the same. However, this time you are using the number of periods, which is 3, and the interest, which is 2%. Look at the small excerpt of a much larger table. In the 3 row, directly under 2%, the factor is 1.0612. That gets typed into the workbook cell under amortization factor from the table below. As in previous problems, 250 is typed into the workbook cell under PV. The math is now very easy. In the workbook cell under FV, type an equal sign, highlight the 250, type an asterisk denoting multiplication, highlight the 1.0612, and press Enter. Once again, the result is $265.30. The next 2 examples are sort of the opposite of what we have been doing. Rather than looking at an expansion of money using compound interest, this formula tells how much money needs to be put into an interest-bearing account to achieve a particular goal. There are new input numbers to look at for this problem. In this case, $2,500 is entered into the workbook cell next to future value, 3% is entered into the workbook cell next to interest, and 3 is entered into the number of periods workbook cell. The format on the screen uses cell references to fill in the function line to save time. The function is entered as follows. In the workbook cell under PV, type an equals, PV, and an open parenthesis. Highlight the 3%, type a comma, highlight the 3, type a comma, type a 0, and another comma, type a minus sign, highlight the $2,500, type a close parenthesis, and press Enter. This indicates that to have $2,500 after 3 years at 3%, $2,287.85 needs to be deposited. Like above, there is an amortization table that can be used for this calculation too. Using the same input numbers, type 2,500 into the workbook cell under PV, look at the row in the table for 3 years and move across to the 3% column. The number there is 0.9151. Type 0.9151 into the workbook cell under amortization factor from the table below. In the workbook cell under FV, type an equals, highlight the 2,500, type an asterisk, highlight the 0.9151, and press Enter. Funny thing, it comes up with the same answer that the function above did. The Excel functions also allow calculating how much interest an investment needs to earn to reach a goal. In this case, the investment needs to triple. It doesn't matter what the number is used for the present value as long as the future value is 3 times the present value. This will also work for any multiple that is chosen. For this example, $100 is put into the workbook cell next to present value. $300, that's 3 times 100, is put into the workbook cell to the right of future value. Finally, there is only 10 years to reach this goal. 10 is entered into the cell to the right of the number of periods. In the format, the numbers are again automatically entered using cell references. To do the function, into the workbook cell under Rate, type equals, rate, followed by an open parenthesis, highlight the 10, type a comma, a 0, a comma, and a minus. Highlight the 100, type a comma, highlight the 300, followed by a close parenthesis, and press Enter. The interest rate needed to triple an investment in 10 years is 11.6%. The corollary to this is knowing the interest rate, but not knowing how many periods are necessary to reach a goal. In this case, the present value is $100 and the future value is $200, doubling the amount. The prescribed interest rate is 7.5%. In the source number cells above the format, enter 100 into the workbook cell next to present value, 200 into the workbook cell next to future value, and 7.5% in the workbook cell next to interest. Again in the format, the numbers are automatically entered using cell references. The formula starts in the cell under N with equals NPER, followed by an open parenthesis. Highlight the 7.5%, type a comma, a 0, a comma, followed by a minus sign. Highlight the 100, type a comma, highlight the 200 followed by a close parenthesis, and press Enter. The answer to this problem is 9.58 years. That would be about 9 years and 7 months.